Here's the filtered tea after it's been alkalinized. The pH is maybe around 10 to 11. And here is the calcium hydroxide that was filtered off. I'll be saving this and doing an extraction on this to see if any of the amine was lost in this process, since the solubility in water is a bit lower than when it's in the salt form. So from here, I'll let this sit for a while, and I'm going to set up a simple trap for CO2. I'll be using yeast, sugar, and water, and I'll have a safety trap so that any water that might escape, it'll be trapped in the second bottle. Probably won't be needed since it's very small volume, but I'll be bubbling CO2 in here until I hopefully see some precipitate. So in theory, the idea that I'm trying to test is if I can get the carbonate salt to precipitate out. There's the carbonate salt, and it's fairly insoluble in water, and it's fairly thin, so I'm not sure how well it'll work with a tea, since it's a little thicker and it's a larger volume. This was a 12-ish inch cutting, but it's still small, on the small end, but hopefully it'll have enough to precipitate out. This is a larger thing. I say larger, like 200 milligrams, maybe 300 milligrams in here. So I'm not sure exactly on the solubility, but even if I get a few grains, it's just a proof of concept, and I'll work on it, or someone else can work on this idea. So it was fairly simple. I just made a tea. I did 2 pressure cook pulls on the fresh cactus. I filtered, like a really quick filter, and then I did a hard boil down to half the volume. And once I got half the volume, I reduced the heat to prevent any caramelization. The main thing is you don't want this to get thick. You want, I think it's low viscosity. You want it as thin as possible, but you don't want to add alcohol or anything, since that does affect the solubility of the carbonate salt. So after reducing it down, I let it sit for a day in the fridge, and I filtered off and decanted the tea again, leaving behind the thin layer of pectin that precipitates out. And then I proceeded again to start filtering, or not filtering, to reducing even further. I had around 250 milliliters of the tea still, and I placed it on the cooktop that I have at the lowest setting, around 60 Celsius, and I just left it a very low simmer. 60-80 Celsius is fine. And then as it reduces more and more, you just want to be careful and make sure that it doesn't boil, since you don't want it to caramelize. You don't want any sugars or carbohydrates to thicken the solution. And then afterwards I filtered it once more, and then I added calcium hydroxide, just like with CeeLo. I just added it, but I added a small amount in small portions, and I kept adding, stirring. I checked the pH, added a bit more until the pH was around 11ish, 12. You don't want like a super strong or a very high amount of calcium hydroxide, since you may end up trapping some of the amine while you filter it off later. So that's why I'm saving this, to test if there's a high amount of trapped amine. And since this is the first run, I tend to test everything. And this is the only thing I had to remove so far, besides the pectin. And the pectin I've already tested myself, and there's virtually no amine in there. And then I checked the pH again. It's still fairly alkaline, so there is still a hydroxide amine here, hydroxide ions, and even a small amount of calcium hydroxide as well. Just a very low solubility, so that's why it's a nice choice. Perhaps you can use calcium hydroxide or sodium hydroxide, lye, or maybe calcium or sodium carbonate, wash soda. You may get away with it. I'm not sure how it'll react when you start bubbling the CO2. But I chose calcium hydroxide specifically, since when you start bubbling in CO2, it'll form calcium carbonate, which should precipitate fairly quickly. It'll basically become a white solution. And once you continue bubbling the CO2 in excess, the calcium carbonate should become calcium bicarbonate, which is soluble in the solution. And that's the principle behind this. And if I reach a pH of around just under 7, really, the amine carbonate, like I showed before, it should precipitate out in theory. This is just a first run, proof of concept. I have no idea if it'll work, but that's the idea behind it. So here's the complete setup. This is a yeast, 100 grams sugar, and 300 milliliters of water. It had some drawback from this water container reserve. This is just to filter any impurities that may or may not come over. And then the CO2 bubbles, and eventually it reaches the calcium hydroxide filtered tea. So here's the excess calcium hydroxide. I'm saving this to see if the amine is not here. And here is the, for the most part, most of the precipitate that forms. It's hard to see. Let's see. Most of the precipitate that formed from the bubbling of the CO2. You can see some white on the glass bottom, some precipitate, and it's extremely fine, so it's hard to decant, and I'm not going to attempt to filter, since it'll likely just get trapped or be lost in the filter itself. So the carbonate is extremely fine. You can see here, I'll swirl this, and maybe, and I'll just let it sit here. Maybe if this was more concentrated, it may have been easier to decant, as when it settles, it'll clump up a bit more, like in this case. When it settles, it gets better. So what I'll try to do here, since I know most of the precipitate that formed from the bubbling is in here, I'll try to place it into these test tubes and then try to make a centrifuge. So since this was proof of concept, I just used a random cutting rather than using a pure product to do a back salting. And I'll probably just do that afterwards. I'm getting through finishing a few other projects, so I'll start with a known quantity and then freebase using the calcium hydroxide like I did this procedure, and then attempt bubbling in the water just like I am here. But again, this is with the tea, so it's fairly impure. It's not just water in a compound, it's sugars and everything else that comes with the tea. And yeah, I'll get around to confirming this is the actual carbonate that I'm looking for and share the procedure. So the solids separated and my only evaporating dish is occupied, so I'll probably just leave this in here. And the way I'll test this is I'll add some hydrochloric acid and it should form the hydrochloric salt. And then I'll test to see if it's soluble in isopropanol. And that seems to be the easiest way for me to test the compound, since I don't have any reagent test kits. And then for the meanwhile, I'll keep the bubbling going on, since there does seem to be a small amount of precipitate that formed again. And the pH shows it's slightly acidic, so I think it's the salt, but we'll see. I just remembered I could test with my TLC plates, but I don't have any available, and I don't think just applying it directly would give a reaction. So I just need to make some more plates, and I could also have a backup test to see if there's the purple stain that forms with the 9-hydene.